We're doing question 14. Okay. Now question 14 is a chain rule. So when we differentiate, what we do is we bring the 3 to the front. And we get 3 times x squared plus 2x. You take 1 away from the power, you get 2. The hidden part is you got to differentiate what's in the brackets. And when you differentiate what's in the brackets, you're going to get 2x plus 2. Okay, so that's where your 2x plus 2 comes from. Okay, so once you've differentiated that, bring it back to the top. Now, golden rule here. This has a power, therefore you cannot multiply it. So you're going to multiply this one here, the 3 by the 2x plus 2, and you're going to get 6x plus 6, and that stays where it was as x squared plus 2x squared. That's your answer to number 14. Okay, moving on. Number, which one here? 19, was it? 21, sorry, 21. Now, number 21, okay, is a product rule. Product rule with u and v in it. Okay? So, u is 3x squared. Du dx therefore is 6x. 2 to the front, take 1 away from the power. V is going to be 2x plus 3 squared. Bring the 2 to the front. And then take 1 away from the power. And then differentiate what's in the brackets. And we differentiate 2x plus 3, you get 2. 2 multiplied by 2, 4. 4 multiplied by 2x plus 3, 8x plus 12. Once you finish that, what we're going to do next is we're going to write down the product rule. Do y dx ends up to be u times the v dx plus v times du dx, and then you're going to put them in. U is 3x squared, and you're multiplying that by 8x plus 12. V is what's v? V is 2x plus 3 squared. I'm going to put the v in the second position, and I'm going to put what's it, du dx in the first position. Now, what I'm going to do next is I'm going to multiply 2x plus 3 squared. 2x plus 3 by 2x plus 3. And what that's going to give me is, it's going to put the bracket up here. 4x squared, it's going to be 12x and a 9. And now we're going to multiply that by 6x. Okay? Multiply everything out. We're now getting 24x cubed plus 36x squared. 6x multiplied by 4x squared is another 24x cubed. 6x by 12x, 72x squared. 6x by 9, 54x. Add all your x cubes together. 48x cubed. Add your x squareds together. 108x squared. And then 24x cubed. Oh, sorry, that's gone already. Sorry, excuse me. Just 54x at the end. Okay, so that's that one done. Who got that one now? Okay, a couple of people getting them out. Alright. Now, moving on to 25 and 26. Now, I'm going to split the difference here, guys. The first one I'm going to do using the quotient rule. The second one I'm going to try the chain rule again, just to see if it can be done. Okay, it can be done. Doesn't matter, we're getting it right this time. Okay, so let's change it around. F of x. This means f dash theta dash. That means differentiate once. So you're going to differentiate once, and then you're going to replace x with 1. Alright? Okay, let's see what happens. F of x is going to be root x over root x plus 3, which in turn is x to the power of a half divided by x plus 3 to the power of a half. Now that that's done, you're going to write down the quotient drill. F dash x, or dy dx, equals phi du dx minus u dv dx all over x squared. Okay? U is what? X to the power of a half is phi squared. Sorry, excuse me. Okay? Phi squared. So, u is x to the power of a half. Du dx, anybody? Anybody? A half, x to the power of? Minus a half. V, x plus 3 to the power of? A half, differentiate? A half, x plus 3, power of minus a half. And then we got to differentiate what's in the brackets. What happens when you differentiate x plus 3? You get 1. Okay? And the 1 might as well not exist. Okay? So the 1 can just disappear there. Okay? Now we're back on here. Now, I don't think that's where the problems lie. I think the problems lie in the fractions. Okay? That's where we're getting stuck. Okay? So it's going to be V. V is x plus 3 to the power of a half. U is minus x to the power of a half. Oh, sorry. Sorry, excuse me. It's phi times du dx. So it's phi multiplied by minus a half, x to the minus a half. And then we're on the minus part. And now I'll fix that in a second. Okay, and then we're on u, which is x to the power of a half, and that in turn is being multiplied by a half, x plus 3 to the power of minus a half, all divided by phi squared, which is x plus 3 to be squared to the power of half squared. Now what's the power of half squared? Can anybody tell me? 1. Because you multiply a half by 2 and you get 1. Okay? So just x plus 3 to the power of 1. Okay, this is x plus 3. Now guys, unlike the previous question, what we could do now, and we're well in our rights to do this, it doesn't ask us for f of x it doesn't ask us for f dash x broken down, does it? It asks us for f dash 1. You'd be well in your rights. Now we're going to do this 2 ways. This is the way you do it in an exam. Okay? The way you do an exam is you said, you know what, that's f dash x right there. All I technically have to do now is just replace all x's with 1s. So you're going to end up with 1 plus 3, 4 to the power of a half. Multiply by minus a half times 1 to the power of minus a half. Then you're going to have minus, what's 1 to the power of a half? What's the square root of 1? 1. So you're going to have 1 multiplied by a half, multiplied by x plus 3, which is going to be 4 to the power of minus a half, all over 4. You could do that one fell swoop if you want. Okay? 4 to the power of half is 2, by the way. It means the square root of 4, so I'm just going to put down 2 instead. I will change my mode though. Okay, I'm going to put the brackets in at the start. I'm going to put the 4 on the bottom. I'm going to go to the top. I'm going to go 4. 4 to the power of half is 2. 2 multiplied by minus a half. And then, so it's going to be tricky enough to get everything in the calculator, but you can do it. Okay, then bracket 1, power, minus a half. Oh dear. I'll put the power in first, then put that in there, and then do minus a half. Okay, go down here, close bracket, minus. Now, please remember, there's technically a bracket here as well. Okay, let's do another bracket there. Minus open bracket 1 times a half. Oh, sorry. I'm probably going to do 1 bracket a half. 1 bracket a half, that means 1 multiplied by a half. One multiplied by a half, multiplied by 4 to the power of minus a half, bracket 4 to the power of minus a half. Now that's to be a minus, so you gotta type it there. A half. Now, very important before you sign off on it. Add the 4.
Bracket for the 4. That's 4 bracket, minus a half.
Oh yeah, it can be in or outside the bracket. You can put it inside the bracket if you want. So just give me a second with it. I don't imagine it would be too affected. Alright, so that just counts as a regular bracket anyway, so we're alright with that. Then, do you want it outside the bracket, is it?
No.
It's alright. There you go there. Now, I finally had to close that one off with yet another bracket. Okay? Syntax error. Now. Okay, I'm not happy with the minus half on the outside, and I'll tell you why. Because it's not going to multiply everything, not just the 4. So I'm going to get. Oh, that's it there. Oh, sorry. Minus 5 over 16. Is that the answer? Anybody want to check the back of the book there? Or my solutions even? Would you not? Mistake was made here, okay? The aspect book's minus 3 over 16, so you got to do a quick search. Look at the UDX being plus a half. So change this to plus a half. Now, after doing all that calculator work, you might think all of it is lost. But all you have to do, press the left button and go back and fix it. Don't reset it. Okay, just go all the way back down here. Change that from a minus to a plus. Okay, delete that there. There you go, 3 over 16, okay? So guys, now what we're going to show you next is, that's what you do in a test, but yesterday we had question 24. I want to prepare you for a question like 24 where you can't just put 1 in. You actually have to break it down as far as it will go. So we're going to try that now, okay? So here's what we're going to do. We're going to do x plus 3 to the power of a half is on top because it has a positive power. The 2 is a denominator. It's on the bottom. Do you understand? Okay, Connor? The 2 is on the bottom. X to the power of minus a half turns into x to the power of a half on the bottom. Okay? Minus x to the half on top. On the bottom is going to be 2 because the fraction's underneath. This is a negative power, which means I can transfer it to the bottom. Now guys, what we're going to do next is look at this, and we're going to have a look for a common denominator. Now, all of this is all over x plus 3. Now, what can happen next is, look at both of them, and this one will say, okay, we both have a 2. This one here has an x plus 3 to the power of a half. Okay, so that means I'll give this one an x plus 3 to the power of a half, which means I'll do the same to the top. Now, can anybody tell me what happens when I multiply the two of them by each other now? It's just x plus 3 to the power of 1, isn't it? Because power of a half plus power of a half equals power of 1. For anybody who's confused, y to the power of a half multiplied by y to the power of a half is y to the power of 1, or simply y. So what I'm going to do there is just fix that up right away, rub it out, and we have to the power of a half there. Fair enough? Next part then, this part looks over here and goes, well, I have the green part, but I don't have this part here. So what we'll say is we'll put x to the power of a half beside that one, which means we have to do the same thing at the top. What's x to the power of a half multiplied by x to the power of a half? X. Now guys, look at this now. All over x plus 3. Now, what's going to happen is two things. The first thing is the top line is now going to become, x plus 3 minus x. I'm now going to bring the x plus 3, which is over 1, I'm going to bring it to the same height and turn it upside down. So technically my new denominator looks something like this. My new denominator is going to be 2x to the power of a half, x plus 3 to the power of a half, and then it's going to get multiplied by x plus 3. Now guys, two things can be done here. This is x plus 3 to the power of 1. What happens when I add the two of these together? This one here and this one here. Or when I multiply them. 3 over 2. Yeah? So, going to rub it out. Going to put 3 over 2 in here. Okay? Next thing. The x and the other x cancel. Leaving 3 on top. Now, if I've done this correctly, when I enter 1 in, what happens? It should turn into 3 over 16. So let's find out. It's going to be 3 divided by 2 times 1 to the power of a half, and then 4 to the power of 3 over 2. Alright, now there's two benefits here. This one is a lot easier to enter into the calculator, but what did it take? It took extra time, and it also gave me the prospect of making a mistake. So in a test you have two options. You can just put it all into the calculator right away the minute you do the first differentiation, okay, and then you can put it into the calculator and hope that you don't make a mistake. The second version is you break it down a bit more. Now you should also know how to break it down, because they can ask you a question where you just have to break it down as far as you can go. So as you can see, calculator usage is actually decently tough here, so I'm just going to get rid of everything there. I have to start again. Now what I did there was I didn't press the power button. Okay, so you can actually see it's good practice to be able to type all this in. Okay, and then we're going to go 4 brackets 3 over 2. How do I get rid of this now? No, that doesn't do it. Oh, I have an idea to save it. I'll just put a 1 down here, because 1's the same thing. Okay, so because 1's the same thing, power bracket 3 over 2. So look, 3 over 16. It's correct, okay? Okay guys, number 26, yeah? Okay, sorry, 26, yeah. Now, we're going to attempt number 26 using the chain rule, just to see if it can be done. Is it advantageous? So far I'm favouring the quotient rule at the moment, but we'll see how this one goes, okay? Will somebody look up the answer in the back of the book before we begin, just so I know what I'm aiming at? Okay, so guys, f of x equals root x plus 1, or say x minus 1 all over root x plus 1. What we do next is x minus 1 to the power of a half and x plus 1 to the power of a half. What I then can do, I can do the quotient rule like last time. Everybody's seen me do the quotient rule. Another option, I just wanted to make you aware of it, is I can say this: f of x equals x minus 1 to the power of a half multiplied by x plus 1 to the power of minus a half. In this case, it's a product rule, and that's u and v. U is x minus 1 to the power of a half. This means that the u dx is going to be a half x minus 1 to the power of minus a half. V is x. Oh, sorry, I forgot to differentiate the brackets. Differentiate the bracket, what happens? It turns into 1. So it didn't make a difference, did it? Okay. Connor. Sorry. Okay. Next part is phi equals x plus 1 to the power of a half. We differentiate the front and we get, oh sorry, minus a half, you're correct. So the v dx is going to be, bring that minus a half to the front, take 1 away from the power, and then differentiate what's in the brackets. What happens when we differentiate x plus 1? 1 and 0, which is just 1. Alright guys, so the 1's don't matter, do they? Multiply anything by 1 is still the same number, so the 1's don't matter. Now, write down the product rule. in 1 second. Just going to keep this list to the side because you need it down here. Okay, so guys, the card here, okay. What we're saying is this is U and V. Now we're going to write down the product rule. The product rule being U times the V dx plus V times the U dx, all nothing else, okay? So U is x minus 1 to the power of a half. The V dx is minus a half. It's multiplied by minus a half. Excuse me. X plus 1 power minus 3 over 2. That's the first part. The second part I'll do in green. Plus V, which is x plus 1 to the power of minus a half, times du dx, which is a half, x minus 1 to the power of minus a half. Now guys, here's where you got to be careful. Okay? Anything that has a positive power stays on the top. Anything that has a negative power goes on the bottom. So I'll show you now. This one here, top or bottom? Top. Okay? X minus 1 to the power of a half. The minus 1 is on top. The 2 is on the bottom because it's a fraction. This one here has a sorry guys, I made one mistake with my bracket there, and I'm going to show you what it is. This minus 3 over 2 should be only outside it should be only outside this bracket here, which means that the difference is this minus 3 over 2 is only affecting the x plus 1, and the second bracket should be on the outside. What I just rubbed out there meant something completely different than what it was meant to. Okay? Thus, this shape, where the bracket is located, changes completely what it's about. Okay? So guys, this one here is a negative power, which means it goes on the bottom. X plus 1 to the power of minus, plus 3 over 2, or just 3 over 2. Okay? After that, we're now on the green one. Okay, plus it's going to be 1 divided by x plus 1 to the power of a half, and then the other one's going to be there's the 2 there as well, and then there's also going to be a x minus 1 to the power of a half. Now guys, here's the tricky part. Okay, now what we got to do here is the following. Okay, this one here looks at the 2 and goes, oh, I have a 2 as well. I don't, however, have this one here doesn't have x to the power of 3 over 2. What do I need to add in here on the bottom to make that happen? Who said that? Well done, Stephen, that's a great spot. Now what Stephen is telling us here is this. Stephen's saying is that x plus 1 to the power of 3 over 2 is the same thing as your current x plus 1 to the power of a half. But you also could do adding on extra x plus 1 to the power of 1. So when you add the powers, it turns into 3 over 2. Is that alright? Now, okay, if I multiply x plus 1 on the bottom, I must also do it for the top. This one here to the left is lacking what? What is it lacking, guys? It doesn't have the x minus 1 to the power of a half. X minus 1 to the power of a half on the bottom, which means you also got to do it to the top. Now look what happens now. Very complex, right? Minus 1 stays where it is. What's x minus 1 to the power of a half multiplied by x minus 1 to the power of a half? X minus 1, perfect. Next one, 1 multiplied by x plus 1? Plus x plus 1, no bother. Okay, on the bottom, 2. You can do either, doesn't matter. X plus 1 to the power of 3 over 2. And then after that, x minus 1 to the power of a half. Now guys, what happens on top is, it's going to be minus x plus 1. The x's will cancel, leaving 2. Okay? So the full top is just going to leave 2. Okay? And then once we got to this stage, this cannot be broken down any further. So if you had a question where you had to break it down as far as possible, this is as far as you can go. However, in this question, we would have been well within our rights to replace, what number are we replacing in? 5 over 4. We could have done x equals 5 over 4 straight away. But it's not really complex calculator work to do that. Like, we're not talking 1 anymore, we're talking fractions within fractions within fractions. It's very difficult. So you might be advised to try it out if you can. If you're that good on the calculator, work away. If you're not that good on the calculator, break it down until it's something a bit more manageable, like this here. And now, all we're going to do now is we're going to change anywhere we see x, we're going to put in 5 over 4. So it's going to be 2 times 2. Now, what's 5 over 4 plus 1?
9 over 4.
9 over 4. 9 over 4 to the power of 3 over 2. What is x? What is 5 over 4 minus 1?
1
A quarter to the power of a half. Now all of a sudden you've turned something that could be absolutely gigantic into something a lot more manageable. Okay, so 2 divided by 2 bracket 9 over 4 to the power of 3 over 2. Okay, then we're going to drag it back down again, do a quarter. Okay, and then we're going to do a quarter to the power of, what is it, a half? Okay, and then put equals, are you going to get 16 over 27? Is that good?
Yeah.
Okay, perfect, thank you. Okay.
Decimals, would you get the same?
Just put it in, actually, right. Shh, lads, somebody please tell me what we did today.